Quantum physics is a fascinating and complex branch of science that deals with the behavior of matter and energy at the atomic and subatomic level. It is a relatively new field that has revolutionized our understanding of the universe and has led to the development of many modern technologies. One of the key principles of quantum physics is the concept of wave-particle duality. This principle suggests that matter and energy can exhibit both wave-like and particle-like behavior, depending on how they are observed or measured. This means that particles such as electrons and photons can act like waves, with characteristics such as interference and diffraction, and can also act like particles, with characteristics such as momentum and position. Another important principle of quantum physics is the uncertainty principle, which states that it is impossible to simultaneously determine the exact position and momentum of a particle with complete accuracy. This means that the act of measuring one property of a particle can affect the other property, and that there is always a degree of uncertainty involved in any measurement. Quantum physics also deals with the concept of entanglement, which occurs when two particles become linked in such a way that the state of one particle is dependent on the state of the other, regardless of the distance between them. This phenomenon has been observed experimentally and has important implications for fields such as quantum computing and cryptography. One of the most famous and bizarre aspects of quantum physics is the idea of superposition. This principle suggests that particles can exist in multiple states or locations simultaneously until they are observed or measured, at which point they collapse into a single state or location. This means that a particle can be in two different places or states at the same time, and only when it is observed does it choose a particular location or state. Quantum physics has many practical applications, particularly in the field of electronics and computing. For example, transistors, which are used in many electronic devices such as computers and cell phones, are based on the principles of quantum mechanics. Quantum computers, which are still in the experimental stage, could potentially solve complex problems much faster than classical computers. In conclusion, quantum physics is a fascinating and complex field that has fundamentally changed our understanding